You've seen them, right? If you've ever been in a modern subway, those sleek glass doors that just glide open, perfectly in sync with the train, they look so simple, so elegant. But let me tell you, behind that glass is an absolutely incredible system of engineering, designed for decades of flawless, safe operation. So today, we're going to pull back the curtain and see how they really work.
Here's what we're covering. First, we'll look at the problem these doors were built to solve. Then, we'll get to know the system itself. After that, we're going to break it down into two parts: the incredible brawn and the super sophisticated brains. Then, of course, we'll dive into all the safety features, before zooming out to see why these doors are such a game changer for our daily commutes.
All right, let's kick things off. First things first, why do we even need these super complex doors? Well, let's talk about the platform problem, and why a simple, open space just doesn't really cut it anymore for modern transit.
Well, think about it. An open platform has some issues. There's the really obvious, scary one, someone accidentally falling onto the tracks. But it's more than that. You know that blast of wind and noise that hits you every time a train comes screaming through? Yeah, that. Plus, trying to heat or cool a station that's wide open to the tunnels is a massive waste of energy. It's really a whole bunch of problems just waiting for one good solution.
So, faced with all those problems, engineers came up with a pretty elegant, high-tech solution. The one we're going to dig into is the platform screen door system, and we're getting all our juicy details from the actual engineering specs for the new monorail at the King Abdullah Financial District.
So, what exactly is a platform screen door, or PSD? Well, at its core, it's a full physical barrier. It completely separates you, on the platform, from the tracks. And yeah, its number one job is passenger safety, but it also has these awesome side effects, like making the platform way more comfortable and the whole station a lot more efficient.
And this table right here, this shows you just how tough the assignment is. I mean, it's not enough to just build a wall, right? The system has to be perfectly safe. It has to be synchronized with the train down to the millisecond. It's got to be efficient enough to handle a chaotic rush hour, and it needs to be so durable and so well integrated that it becomes like a seamless part of the station's entire nervous system. No small task.
Okay, let's start with the muscle of the system, the pure, heavy-duty physical engineering. This is the brawn.
So, the heart of the system is what you're looking at here. You've got this massive steel structure that anchors the whole thing to the platform. Up top, in that header box, that's where all the motors and the control units live. The doors themselves, the leaves, are made of this super strong laminated, tempered glass. And down at the bottom, a reinforced threshold is built to handle millions of footsteps. Every single piece is just heavy duty.
And get this number just shows you the level of engineering we are talking about. The main structure isn't designed to last for a couple of years. No, its minimum design life is 30 years. 30! With just one big overhaul planned at the 15-year mark. This isn't just about being durable, it's about these massive public investments. This is infrastructure that's meant to last for generations.
And to make it 30 years, these things have to withstand some incredible forces. I want you to picture a packed rush hour crowd, all pushing against the glass with a force of 3,000 newtons for every single meter. Or that crazy blast of wind from a train that's not even stopping. These doors even have to take a direct heavy hit, like someone just slamming a heavy suitcase right into them, and come away with no permanent damage. That kind of toughness is only possible if you use serious industrial-grade materials, like hot-dip galvanized carbon steel and high-end stainless steel.
But you know, all that strength is pretty useless without intelligence. So now, let's look at the brains of the operation, the complex control network that makes this whole thing work in perfect harmony.
At the very heart of the system's intelligence is just insane reliability. It's engineered for what they call a mean time between failures, or MTBF, of 40,000 hours. Now, to put that into perspective for you, that's more than 4.5 years of non-stop 24/7 operation, without a single system-level fault. Incredible.
So how on earth does it achieve that kind of reliability? Through this precise, lightning-fast chain of command that happens every single time a train pulls in. First, the main train signaling system gives the OK, telling the platform the train is perfectly positioned. Second, the platform screen doors control, the PSC, sends the open command out to all the doors. Third, each individual door has its very own little brain, a door control unit, or DCU, that gets the command. And finally, the DCU fires up the motor and the doors glide open. And this whole dance, it happens in about 3 seconds.
So it's best to think of it like a nervous system, right? The PSC is the central brain, making all the big decisions for the whole platform. Each DCU is like a local nerve center, just focused on controlling its one door.
If something goes wrong, station staff can use a local control panel to take manual control. And the whole time, a network of sensors is constantly feeding information, like door position or potential obstacles, back to the controllers.
Okay, so we've established the system is strong and it's smart. But what happens when things go wrong? Let's talk about the layers and layers of safety designed to handle pretty much any emergency you can think of.
One of the key safety features is that there are actually two different kinds of doors. You've got the automatic sliding door, the ASD, that's your everyday workhorse for getting on and off the train. But right next to it, you'll see an emergency escape door, or EED. This one's different. It's a single door on a hinge that swings open manually. Its one and only job is to let people evacuate if a train stops in the wrong position and the main doors don't line up.
And what about getting, your backpack or something caught in the doors? This quote from the engineering spec is just fantastic. Basically, if a closing door feels an obstacle, it doesn't just keep pushing. It immediately backs off, waits a beat, and tries again. If it fails 3 times in a row, it just assumes there's a serious problem, gives up, and slides all the way open while sounding an alarm for help. And get this, the system is so sensitive it can detect something as thin as 10 millimeters.
And the protection is built in layers, kind of like a fortress. First layer, in a true emergency, passengers trapped on the trackside can actually open the doors manually. For the staff, they have bypass switches to isolate one faulty door without having to shut down the entire platform. Then you've got the ultimate guardian, a critical, hardwired safety loop that physically stops the train from moving an inch unless it gets confirmation that every single door is closed and locked. And finally, a laser system acts as a constant watchdog, scanning the gap to make absolutely sure no one and nothing is left behind.
So, when you put all this incredible engineering together, the brawn, the brains, and all those safety systems, you start to realize this whole technology is about so much more than just a door.
When you add it all up, you see that platform screen doors are a truly transformative technology. They don't just enhance safety, they completely change the entire platform environment. They make climate control possible, saving energy and making things more comfortable. They slash that deafening noise and wind. And by creating a more orderly and predictable space, they actually speed up how quickly people can get on and off the train. There's a really good reason they've become the absolute gold standard for modern transit systems all over the world.
This entire system is just a perfect example of incredibly complex engineering hiding in plain sight, working flawlessly every single day to make our lives safer and just a little bit easier. It really makes you wonder, the next time you're standing on a platform, waiting for your train, what other invisible engineering will you start to notice?